Hello, class ninth. So, we have been studying chapter number 12, that is sound. Yes. So, in last time we studied what is speed of sound, amplitude, loudness, all these topic, and what is compression, rarefaction. So, we studied all these, and that we know that to travel the sound need the medium. Yes. Today we will study what is reflection of sound. Yes, we will study about the reflection of sound. Okay, so this topic is going to be easy. You already know what is the meaning of reflection. Yes, what is reflection? In lower classes you studied about the reflection of light. Yes, in lower classes you studied about the reflection of light. So when the light falls on the any smooth surface, then it bounces back. Yes. So the light returns. This is called a reflection of light. Yes. So the same thing is here, reflection of sound. Okay. So like light, sound gets reflected at the surface of solid or liquid and the follows the laws of reflection. Yes, it also get reflected. Okay, sound also reflected just like light. So there are two laws related to reflection of law. There are two laws related to reflection of law. Law number one. What is the law number one? According to the law number one, the angle of incidence is equal to angle of reflection. Yes, the angle of incidence is always equal to angle of reflection. It means what? When the light falls or when the sound fall, okay, because here we are talking about the sound, so we will talk about the sound waves. So when the sound waves fall on the surface, then suppose the sound waves are falling at 90 degree, suppose the sound waves are falling at 60 degree. Okay, suppose the sound waves are falling at 60 degree, suppose the sound waves are falling at 60 degree. So as the sound waves incident, they will reflect. So when the sound waves reflect, the sound wave will reflect at the same angle, means at 60 degree angle. Okay. Law number two is the incident ray, reflected ray, and normal are at the point of incident, all lies in the same plane. Yes, incident ray means the sound waves. Okay, which is falling. Okay, reflected ray means which is bouncing back. Okay, so the sound waves which is incident and then reflected, and the normal means perpendicular from the point where they are falling and reflecting. Okay, as you can see in the picture, the perpendicular is at the center, which is actually shown as a screen and given by the point O, which is called point of incidence. Okay, so incident ray, reflected ray, normal means perpendicular are at the same point. Yes, all in the same plane. Okay, so you can easily do this activity at home. So what will you do? You will take two pipes of the same length and arrange them on a table near a wall. Okay, you can arrange near the metal plate. Keep a clock near the open end of one pipe. Yes, you will keep a clock open a one end of pipe, or you can keep put a bell. Okay, and try to hear the sound from the another pipe. Okay, so by adjusting the pipe, so now measure the angle of incidence and reflection. You can measure easily. So then lift the sound pipe and try to hear the sound. Yes, lift the second pipe and try to hear the sound, and it will be seen that the angle of incidence is equal to the angle of reflection. Yes, the incident ray and the reflected ray normal all lie in the same plane. I hope you understood. Now let's move on the next point. Okay, so let's study about the echo. Yes, what is echo and what is reverberation? So if you clap near a reflecting surface, or if you shout, yes, near like a tall building, near the tall building, or near the mountain, then you will hear the same sound. Yes, if I shout Vikas, then I will again hear the same sound. Okay, if I will clap, then after some time, after a second, I will again hear the same clap. So this sound which we hear is called echo. Okay, it is caused due to the reflection of sound. Yes, it happens due to the reflection. So to hear an echo clearly, the time interval between the original sound and echo must be 0.1 second. Yes, actually the difference between sound must be 0.1 second, then you can easily hear. Okay, so as we know, what is the speed of sound? What is the speed of sound? The speed of sound is 344 meter per second. Yes. So the distance traveled by sound in 0.1 second will be, if we multiply 344 meter per second into 0.1, then 34.4 meter. Yes, it means what? In 0.1 second, the sound travel 34.4, because the speed of sound is 344 meter per second. Okay. So to hear an echo clearly, minimum distance of the reflecting surface should be half of this distance. Yani ki that is 17.2 meter. Yes. So remember kids, to hear the echo, the minimum distance of the reflecting surface should be half this distance, means 17.2 meter. Yes, because sound in 0.1 second, the sound travel 34.4 second. So if the minimum distance is 17.2, means the minimum distance of the reflecting surface is 17.2 meter away, then you can hear. Okay, that is the meaning of echo. Okay, now what is reverberation? So echo may be heard more than once or due to repeated or multiple reaction of sound. Yes, so if you are near the tall building, then you hear the same sounds. Like if I say Vikas, then I will again hear Vikas. But sometime it happens that we hear the echo again and again and again. Yeah, like if I shout Vikas, then I will again hear Vikas, 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 Vikas. So slowly, gradually, the sound will decrease. Okay. So echo may be heard. Echo may be heard more than once due to repeated and multiple reflection. Yes, due to multiple reflection, or due echo can be heard again and again. Mm, so due to multiple reflection of sound from several reflecting surface. Yes, multiple reflection can occur if there are several reflecting surface. So this causes a persistence of sound. Yes, this causes a continuation in sound, persistence of sound, that is called reverberation. Okay. So in big hall, auditorium, actually reverberation occur in big hall, auditorium. So they use some. So that's why they, to reduce the reverberation in cinema hall, especially in cinema hall, reverberation occur, but the roof of cinema hall and wall are actually covered by sound absorbing material. Yes, actually it is covered by sound absorbing material. For example, compressed fiber board. Yes, compressed fiber board, rough plaster, draperies, drapers, they are used to absorb the sound. Yes, which material are used to reduce the reverberation? Rough plaster. Okay, rough plaster is done, or drapers, or fiber board. Okay, I hope you understood. Now let's move on the next point. Okay, so let's see some multiple uses of this multiple uses of reflection of sound. Yes, multiple uses of reflection of sound. So as we know that stethoscope. Have you heard about stethoscope? Yes, stethoscope is used by doctor. Yes, so doctor use it to hear the sound. So sound from the human body through a stethoscope, and you, if you ever heard megaphone, horn, musical instrument, like trumpets. So in all these, actually all these are actually designed to send sound by multiple reflection in a particular direction, yes, without spreading in all direction, yes. So they are designed in a such way, so they are used to send the sound by multiple reflection, yes, in multiple reflection occur in these, but they send the sound in only one direction, okay. So stethoscope, horn, megaphone, trumpet, so all these are based on reflection of sound, okay. Point number 2, doctor listen to the heartbeat, reaches to the our doctor listen to our heartbeat that reaches to doctor's ear by multiple reflection, yes, that is actually stethoscope which is based on it. Generally, the ceiling in the cinema halls and auditorium are covered. Yes, ceiling in cinema hall and auditorium are covered, and even the to protect the reflection, they use plaster. Means means that they use rough plaster, drapers, compressed fiber. So and so generally the ceiling in cinema hall and auditorium are covered so that the sound after multiple reflection reaches all part of the hall. Yes, to stop the reverberation and to send the sound by in all direction. The auditorium cinema hall are curved in shape, yes, they are actually curved shape, yes. Why the cinema hall are in curved shape? Because to send the sound in all part of the hall, all part of the cinema hall, all part of the auditorium, okay. Sometime a curved sound board is placed behind the stage, yes, sometime it happens a curved sound board is also placed behind the stage so that sound after multiple reflection spread evenly across the hall. I hope you understood these uses, okay. Now let's study about the range of hearing. Let's move on the next point. Well, kids, everyone has a different range of hearing. Yes, everyone has different range of hearing. Human can hear different frequency range sound. Different animals hear different frequency sound. Some animals can hear the sound, even the soft sound that we cannot hear. Yes, they can hear. Some animals can hear, and many animals can hear the loud sound. Yes, so its range of hearing depends upon the frequency. Yes, range of hearing actually depend upon the frequency. Yes, range of hearing actually depend upon the frequency. So kids, human being can hear the sound frequency between 20 hertz to 2000 hertz. Yes, what is the range of hearing of human being? 20 hertz to 2000 hertz. Yes, and sound whose frequency is less. So I hope you understood that human being sound hearing capacity is 20 hertz to um, uh, to 20,000 hertz, and above this or less than this human being cannot hear the sound. Now the question is, what is infrasonic sound? What is infrasonic sound? What is infrasonic sound? Sound which frequency is less than 20 hertz. Sound which frequency is less than 20 hertz is called um, infrasonic sound, okay. So this sound cannot be heard by us. Human being cannot hear this because this sound is very less frequency, it is very soft and we cannot hear. But there are many animals who can hear the infrasonic sound, like elephant, rhinoceros, dogs, whales, okay. uh, they can hear the infrasonic sound, okay. And they also produce infrasonic sound, yes, but we cannot hear, even we cannot feel it, okay. Now what is ultrasonic sound? What is ultrasonic sound? Sound whose frequency is more than 2000 hertz. Yes, sound whose frequency is more than 2000 is called ultrasonic sound. Yes, this sound is very irritable sound, and many uh, animals like dolphin, bats, so they produce the sound, they produce ultrasonic sound, and they can also hear the sound. Okay. Okay. And how does bait, because bait fly at night, and how does the bait find the prey for eating? So actually bait is used the reflection of ultrasonic sound waves. Yes, it produces ultrasonic sound waves. When these ultrasonic sound waves strike to any insect, or insect to any obstacle, it again bounce back and reaches to bait, and the bait understood that yes, I got my prey. I hope you understood. Now let's move on the next point. So kids, infrasonic sound has frequency less than 20 hertz, and ultrasonic sound has frequency more than 2000 hertz. So what are the uses of ultrasonic sound? Okay, you might have heard a word which is called sonography. Yes, sonography is actually based on ultrasonic sound technique. Okay, so ultrasonic sound is used to clean objects like electronic components. The components to be cleaned are kept in a cleaning solution, and ultrasonic waves are sent into the solution. Due to the high frequency, the dirt particle gets detached from the component. Yes, so ultrasonic sound is actually used to clean the electronic components. Yes, because when such components are kept in a cleaning solution, that time ultrasonic sound waves are sent. So due to high frequency, the dirt particle get detached from the component. Yes, isn't it amazing way to cleaning? My God, we can also clean our kitchen utensil. Okay, next point. Ultrasonic sound is used to detect cracks in metal. Yes, it can find out the cracks. When ultrasonic sound will incident on any metal, if there is any crack, then it will get reflected. Yes, ultrasonic sound is used to detect the cracks in metal block. Ultrasonic waves are sent through the metal block, and if there are cracks, the waves are reflected back and the cracks can be detected. Yeah, it is very outstanding technology to detect the crack in heavy machines. Yes, and in those in those heavy machines which are not easy to open. Yes. Point number 3, ultrasonic sound is also used in scanner. Yes, for getting the image of internal organ and human body. Yes, we know sonography. Sonography is done. Sonography is done to get the image of internal organ and human body. So for it, ultrasonic sound is used. Yes, well, ultrasonic sound can be dangerous also if it is used more. Okay, remember this. Well, next point is ultrasonic sound is used to break small stone formed in the kidney into fine grains so that they are removed through the urine. Yes, this is the best uh, thing, that is the use of ultrasonic sound. It helped if you have kidney problem. Kidney problem means the small stones formed in the body, which are actually not stone. Okay, don't think that they are really stone. So it is used to break those stone formed in the kidney. Yes, so into fine grains so that they are removed through the urine. Okay, I hope you understood. Now let's study a new topic, that is called sonar. Let's move on the next point. Okay, let's study about the sonar. Yes, so what is sonar? Let's first what is the full form of sonar? Yes, what is the full form of sonar? So the full form of sonar is sound navigation and ranging. This is the full form of sound sonar. Okay, so what is sonar? Sonar is actually a device. Yes, which is actually based on the reflection of light. Okay, which is mainly used in the ship or in marine. Okay, submarine. So sonar stands for sound navigation and ranging, and it is a device which is used which uses ultrasonic sound waves to measure distance and direction and speed of underwater object. Yes, it is used to measure the direction, distance and speed of any underwater object. Suppose you are in the Titanic ship going to America, and if there is any ice big rock will come in front of you. Then if you are not able to see, or if there is just at the bottom of the ship if any ice rock, then the ship can strike to the ice. So but sonar can protect it. So what happens actually, sonar has a transmitter and a detector installed in the ship. Yes, so transmitter actually send the ultrasonic sound waves, means transmitter produce the ultrasonic sound waves, and which travel through the water, and after striking to the object in the seabed, it is reflected back. Yes, after striking it reflects, and the reflected sound waves are detected by the detector which is installed in the sonar. Yes, so in this way it can be easily calculate what will be the actually distance. So the distance of the object can be calculated by knowing the speed of sound in water and the time taken between the transmission and reception of ultrasound. Okay, so the distance of the object can be easily calculated by knowing the speed of sound. Yes, what is the speed of sound in water, and what time is taken between the transmission and reception of the ultrasound. So suppose if the time taken for the transmission and reception of the sound is t, and the distance traveled is total 2d, means 2d means d plus d, 2d. Okay, d is actually from transmitter to transmitter to seabed, and from again seabed to detector is again d, so t plus d, 2d. So the distance will be d is equal to v into t divided by 2. D is equal to v into t divided by 2. Yes, this is the formula for the calculation. Now let's move on the next point. So this is the structure of human ear, as you can see. Yes, you will, I think you cannot see here clearly, but you can do a work, you can check out the diagram um, in your book, and you can draw it. Okay, practice it. Okay, so structure of human ear. So the outer ear is called pinna, which collect actually sound waves. The sound waves passes through the ear canal to a thin membrane called eardrum. Yes, you already know because we have already studied about human ear, so I am not going to explain anything. So when the eardrum vibrates, the vibration are amplified by three bones of the middle ear called hammer, anvil and stirrup. The middle ear then transmit the sound waves to inner ear. In the inner ear, the sound waves are converted into electrical signal by the cochlea and sent it to the brain through the auditory nerves. The brain then interrupts the signal as sound wave. So our actually ear is divided into three part: outer ear, middle ear, um, and inner ear. Yes, outer ear, the outer ear part is called pinna, which collect the sound and it transmit to the eardrum. Eardrum kan ka parda, you know. So the work of eardrum is actually it when the sound fall on it, it start vibrating and amplify the sound, and the amplified sound is sent into the to the middle ear. And in the middle ear mainly there are three bone, HAS, so hammer, H for hammer, A for anvil, S for stirrup. So these were the vibrations sent by eardrum. They reaches to the middle ear, which amplify the vibration, and it is sent to inner ear. Yes, in the inner ear, the sound is converted into electrical signal by cochlea, and which is sent to the brain, and brain gives order that yes, you are listening something. That is the process, and it is very easy. Now, let's move on the last point. Okay, it's time to ask question from you. So, question number one is define ultrasonic and infrasonic sound and write the uses of them. Yes, what are the uses of ultrasonic and infrasonic sound? You know that kids, sound whose frequency is less than 20 hertz is called infrasonic sound, and sound whose frequency is more than 2000 hertz is called ultrasonic sound. And elephant, rhinoceros, dogs, they can hear infrasonic sound. And dolphin, bats, they can hear dolphin, bats, rats, they can hear ultrasonic sound. Okay, and human hearing frequency is 20 hertz to 2000. What are the uses of ultrasonic sound? Ultrasonic sound is used to break small stones, yes, formed in the kidney through into fine grains, so that they are easily removed through the urine. And ultrasonic sound is also used as an ultrasonic sound scanner for getting image of internal organ and human body. Okay, otherwise ultrasonic sound is used to detect the crack in metal. Okay, so ultrasonic sound waves actually sent through the metal block, and if there are any cracks, then the waves are reflected back and the cracks can be detected. Okay, otherwise it is also used to clear the electronic components. Question number 2, what is echo and what is reverberation? Yes, what is echo, what is reverberation? So echo means if we shout or clap near a reflecting surface like tall building, then we hear the same sound again. This sound we hear is called echo. It is caused due to reflection of sound. Okay, to hear the echo clearly, the time interval between the original sound and echo must be 0.1 second, and we know that the speed of sound what is 344 meters per second. It means the speed of sound in air is 344 meter per second, means the distance will be traveled by the sound in 0.1 second will be 344 meter. Yes. Okay. Now, what is reverberation? Echo may be heard sometime more than once. So, due to the multiple reflection of sound for several reflecting surface, this causes persistence of the sound, which is called reverberation. Question number 3, what is sonar? Well, sonar stands for sound navigation and ranging. It is a device which is used ultrasonic sound waves to measure distance, direction, and speed of ultra underwater speed in underwater. Yes, actually, sound has a transmitter and detector installed in the ship. Yes, the transmitter produce ultrasonic sound waves and which travel through the water, and after striking the object in the bed sea is reflected back to the detector. Well, we can easily find the distance by a formula which is called d is equal to v into t divided by 2. Yes, this formula is used. The distance of the object can be calculated by this form by knowing the speed of the sound in water. So this formula can be used, d is equal to v into t divided by 2. Question number 4, write a short note on human ear. Yes, human ear. Well, structure of human ear, if we talk about it, the outer ear called pinna collect the sound waves. The sound waves are passed through the ear canal to a thin membrane called eardrum. The eardrum vibrates. The vibration are amplified by the three bones of the middle ear called HAS, hammer, anvil, stirrup. And in the inner ear, the sound waves are converted into electrical signals by the cochlea and sent to the brains through the auditory nerves. The brains then interrupt the signal as sound. I hope you understood now. We'll meet in next class with a new chapter. Till then, bye bye.